introduce Ioannis Pavlopoulos, who is a postdoc at the University of Athens, and so a Google fellow.
Google Jigsaw Fellow, yeah.
So we plan to collaborate with Leo in this project funded by Google called Conversational AI. And so you will talk about toxicity in online classes.
Thank you, Thomas. Thank you also for the invitation. Thank you all for being here. So I'm Ioannis Pavlopoulos, also called John in articles. And well, continuing the introduction, I also have interest in other natural language processing tasks, such as sentiment analysis, and biomedical image captioning and legal AI, but this talk will focus on research findings, recent research findings on toxicity detection in online conversations. So starting right away, there are comments online in social media and other platforms such as news portals where readers and become users and comment below on news articles, and this happens to get feedback for the news article authors and engage the readers and build customer loyalty. But the problem is when these user comments become toxic or abusive, I'll use both these terms, containing profanity, bullying, and hate speech sometimes. So continuing with this example with news portals, moderators are employed, and their job is to reject such abusive comments and avoid reputational damage, fines at other cases, and certainly putting off readers who will stop reading. And their job, the job of the moderators, is very hard because they get frequently overwhelmed by the volume of comments daily, and they get they receive this abusiveness. They read it, and the human being is behind the moderator role is affected, certainly. And the readers are also disappointed when non-abusive comments do not appear quickly enough because there are moderation delays. I mean, being read by a moderator. And smaller news portals may be unable to employ moderators, and this leads to shutting off directly the comment section and losing any advantages of using it. So moderators employed use a moderation panel. They read the comment, and they try to see whether it will be rejected or not, and if not, they need to publish it really quick, and they need as much help as they can. So, for example, if they had an automated score, they could rank these comments and had the rejected on top, or maybe the ones that need that are more likely to be accepted on top, so they can just publish it quickly. And also heat maps of words, which we will discuss in this research. It was a finding which is interesting, and also we got very good feedback from moderators, because in lengthy comments or maybe in very long texts, it's difficult for them to read it, and there are times that toxicity exists within a small part of the text. Some moderators were actually excited to use that. Another aspect that we will discuss is how the information of the user can assist technology to take better decisions. So far there were user-specific info incorporated into models, into architectures, but we explored user embeddings to avoid feature engineering in such a way. And I'll start right away about automated and semi-automated moderation, where what works best in practice, at least for portals and such businesses, is that they have the comments, and all the comments are scored by a system. This system could be just a list of bad words, I guess, or a deep learning, a trained deep learning system. And we have one score per comment, which score shows how abusive this text or how toxic this text is, how probably it is that this text will be rejected by a human moderator. Then we have two thresholds. Comments above a rejection threshold will be deleted automatically, and comments also not passing an acceptance threshold also get accepted. So say that this threshold will be 0.3, 0 to 0.3, we would consider it low acceptance threshold. Maybe the administrator of the portal and could let it be accepted directly, and above 0.9 it could be directly rejected. And in between zone, the comments that belong in the zone in between are sent to a human moderator to decide. This could be like implicit toxicity comments, or could be context-sensitive comments that reading the text alone is difficult and human assistance would be required. So the important thing is that we can put in a simple value this coverage score and let a moderator decide how many comments will be seen by the system and how many will he receive to label or to flag. So we have a score that is the comments rejected or accepted automatically, the portion of them, and this can be tuned according to the moderator time. So in busy times, he can set this threshold so that more comments are handled by the system. And in an automated scenario, these two thresholds become one, and we have 100 coverage, meaning that all the comments are seen by the system and the moderator doesn't have to do anything. This would be used by a news portal that cannot employ human moderators. And for simplicity reasons, we'll adopt this scenario, but all models we'll see in this presentation are also can be integrated in semi-automated moderation as well. So I'm going into more about methods. I'll take as granted that you are familiar with neural networks and say a bit more about recurrent neural networks, which you also may be familiar with. So taking a recurrent neural network, we have word embedding. So each word is mapped into a representation, a multidimensional representation, and this word embedding is used as input to a cell. This cell is like a neuron which uses the word embedding and past information. Past information is like the previous hidden state, the previous latent representation of the word seen. So if we unroll this text in the last hidden state of this RNN, this cell will not only use this word embedding, will also use the last hidden state it saw, which remembers the previous text. So it's a good way to represent the text, basically. And one can use just the last hidden state or average hidden states of an RNN and encode the text. So using the last hidden state, for example, we can use a logistic regression on top, a layer, and have a probability that the text will be rejected by a human or not. So what we did is, in a work before a couple of years, that we added an attention, a self-attention mechanism that basically is based on a deep stacked MLP, which is the same for all words, for all hidden states. So each state of the RNN is then used as input to this mechanism. I think it was 4-layered MLP at the time that had the best results. And this scores, in effect, the importance of each corresponding word. So it focuses on the word to see whether the text is abusive or not. And we use these scores, we pass these scores over a softmax and have them normalized to 0, 0, 1. And weigh the hidden states to get a representation, just the one, the last hidden state one, but now weighing all words based on the attention scores. And again, take the probability that the text in question will be rejected or accepted. So what we got as a side product of this mechanism is that these attention scores learn to focus on words that are rather suspicious. So if a text is indeed ranked, scored highly, that it will be toxic, then we can ask these attention scores, what words should the moderator see in order to verify or not this judgment. And this was very useful. We'll talk more about it in a while. And we did also an interesting ablation in that work. That is, we removed the RNN. We thought that if attention works that so well, what would happen if we just remove the sequential machine learning, this sequential neural network, and see what happens if we use the attentions alone. So here we see that word embeddings are used as the input to the attention mechanism, and also are used to be weighted with the attention scores and get the probabilities rejection and acceptance. So going into results, we had interesting findings. The first finding which we expected is that RNNs are the best overall against other systems. Other systems such as the convolutional neural network operating on word embeddings and an MLP that was a state-of-the-art at the time, and also a simple, naive, list-based system that uses scored words to judge whether a text would be classified or not as abusive. So RNNs best, and attentional RNN overall better. But the most interesting was that the DA send was surprisingly good. It was, I mean, considering that we removed an RNN using the sequential, the textual sequence as information, it behaves very well. Its performance is very good. This also is, I guess, at the time BERT was not introduced, so BERT now that uses also attention mechanisms, multi-head attention and other attentional models, also not using an RNN, is, I think, related to this finding.
So BERT is the state-of-the-art?
BERT is the state-of-the-art at the moment. It's recently, for the last year at least, put the burden very high at many tasks, one of which is also abusive detection. It was a competition recently where we submitted the results with a BERT which was very high ranked, considering that we did not retrain it from scratch. We used a pre-trained BERT model and just fine-tune it for another task. So another interesting result is that the distance from the baselines is large. I mean, they all performed worse, much worse. So yeah, this is about toxicity detection. And in the last part of this presentation, I'll also talk more about future directions and how this can be better and what are the ways. One of them is to also integrate BERT and an RNN. So see what happens if you use BERT to encode and then on top use an RNN on sentences and build a kind of hierarchical model. But we can talk about it offline, I guess. So another interesting thing is how could we evaluate this attention highlighting? How could we evaluate whether attention really explains the decisions of an abusive and a toxicity detection system? Because there is an ongoing debate about does attention, can attention explain decisions, or is it just noise, or is it so? No proper, at least to my knowledge, evaluation has been performed so far with human assessment on these decisions. And at that moment, we did a small experiment. Again, we used the attention scores to highlight words and get such heat maps. And the intuition by moderator, the feedbacks of the moderators, also pushed us to go on and search this a bit more. So this is an example we saw and we shared with the community about what happens when you give it a toxic text and use the attention score just to highlight. And we can see that if it was such simple examples, it would give you the red color and everything else would be white. And if you give it accepted comments, basically, you would get more a uniform distribution of the attention scores. These heat maps would not attract the attention of the moderator, basically. So in order to assess this attentional model, we used this score as our first model and created two baselines. One baseline would be just to use again a word list, which is I guess the most simple thing one could do. Take this word list, take a list basically which has high probability, a word, a text containing that word to be rejected. So this is just how likely it is for this word to lead to the rejection of a comment. And we made a list, and for each text we use the softmax to get scores for that text. And also a naive baseline that is just random scores to see whether really it was noise that we were getting, or maybe attention really did the job. And we created a small data set of 800, I think, 850 comments and 5 annotators, resulting in each token having a probability that an annotator would consider this as part of a toxic snippet. And we used various types. You can see that our study resulted different types from the toxicity types, but again, each such toxic span was also contained in non-toxic and toxic comments. So the green zone above is how many non-toxic comments contain, for example, ironic spans. And we used correlation measures to evaluate, to estimate how correlated is the scores of humans for these words and the scores of attention, list, and the random baseline. And we see that the attention is much higher in all, in both scores and in both zones, accepted and rejected. It's like agreeing with the human in this.
Question.
Yeah.
The classification of the text up there on the right. So this is automatic, right?
No, this is by humans. This is the goal. Yeah, this is the data set. We created a data set.
And they have to choose, so humans have to choose one of these labels, right?
Yeah, they just highlighted a span, and they said this span is one of these.
Okay, so take, for example, irony. I see rejected and accepted.
So irony, they took a span,
Yeah.
and they just highlighted it, and they just said this is ironic. The text, they didn't know if this would be, if this was a rejected or accepted comment. We did not give them this information, and,
Okay.
and we So we post-processed afterwards and said, look, this span was contained in so many rejected and so many accepted comments. We also wanted to see this, to see whether we'd not like to bias them.
Okay.
So we got this first result, but this is not enough, and we need to take it in take it forward and study in a bigger sample to get more, to test it across more comments. And this is in a Greek data set. We need to go into the English and the English language and also see what happens, and also in much more domains. Because this data set, which humans annotated, was on a news portal and from professional moderators at the time. So there were a lot of parameters.
What's the volume of the data?
This is 1 million comments, and it has some, I mean, talking with moderators, there were times that moderators were biased by the world knowledge. So there could be some sensitive days for which they used to reject more. This means that noise was introduced in the data, but also this means that this is a data set close to real world. So it has interest. Fortunately, this is an open source dataset. It is published. Unfortunately, it hasn't been yet anonymized, and it is scrambled. So we don't have the raw text. We have some scrambled word tokens published. But we are working on releasing a whole version. So going on to a second aspect of that work is how we integrated the user information, how we used user embeddings, and how did that help detecting toxicity in texts. So taking again RNN as an example, we have a logistic regression on top. And what we did is, we said what would happen if we take the bias term and not use it as one term, as one value for all users, but use one bias for each user. So we have one bias value per user. This is, we call it user bias, PUB, UBRNN. And then we thought, what would happen if we had user-specific embeddings? Instead of learning a one-dimensional bias per user, we use a single bias, but we learn a separate embedding vector of multiple dimensions to encode information, basically. This could capture, more information about users than one-dimensional user-specific biases. And we call it user embedding. And this then created a worry. We were worried that there may be very few comments per user to learn good embeddings. So in the third approach, we grouped the users in 4 groups. And you can see on top that we used the green zone, where users were rather accepted when they published a comment, when they sent for publishment a comment, or they were rejected, the red, and in between the yellow, like a gray zone. But we also have the unknown, which is too few comments, and we don't know what happens there. We were also interested to see what happens in this unknown zone. In a first approach, then, we learned a separate one-dimensional bias per user type to see whether the problem had become really easy introducing these 4 zones. We call this type bias, RNN. And going directly into results, again, we used the area under curve. Well, I didn't mention earlier that area under curve is important because it uses many classification thresholds, and you are not just dependent on one tuned threshold for your decisions, and it gives you an overall image. So what we see is that the RNN gets improved by changing this bias, by updating its bias. So the results are always better with all the 4 types. Second observation is that user-specific information is better than user type. So when we had different users, it went better. Yeah.
When I see the value, of course, yes, it is improved, but is it a lot improved because it's just 1 point? Is it significant?
That's a good question. So in order to so it has 2 aspects, this question. The first is, how important is this small increase in terms of toxicity detection results? And the second is, does it matter? Maybe not does it matter. If we use a different seed, or if we use a different hardware, would we get the same results? So starting from the second question, we, in this case, we used the mean value of 3 different, so like ensampling and taking the standard deviation to get more, to secure the results. And for the other question, it's not a big improvement, but considering the large volume of comments seen from moderators every day and considering the impact that has in their work, and I'm just taking the scenario for moderator, there are other scenarios as well, increasing the probability that he won't have mistakes, a comment won't be a likely to be rejected comment won't be published in these zones, because the systems are used to help him see less smaller gray zones, is very important. I mean, there are cases where very toxic comments are expressed in an implicit way. So having, as we'll see, maybe it's a good opportunity to see an example, basically, and answer that on an example. I'll come back to that question in a while. So we have, let's visualize what we learned. We see the bias term, that's the one-dimensional, and we average the other, which has many users. And we see that the green is always negative. Having a negative bias means that it pushes you to not reject. This means that it decreases the rejection probability. So it is something we expected. It validates our intuition. And the same happens with red, which is high, and it's like biasing in favor of rejecting, having a greater probability to reject. The other two are also in between, which we also expect. We also expected, and we try to visualize it more and use principal components and use just the two first to plot it. And we see that there is a gradual progression from low rejection. You see low rejection on the left with the green and going into red, which means that, as you can see here, maybe you can basically, we have a 0.3, which is on the far left, and here we have 0.92. This is the rejection rate. So they seem to be progressing from green to red, which is also expected as a plot, but also nice to see. And now, coming back to this question. So there is a comment that says, "Oh, down to Piraeus." I mean, yeah, somebody understood that message, but in order to understand that message, you need to have an image from sports in Greece. And this is the starting part of a rather toxic phrase for a team in Greece. So it's like the author implicitly stating that the other would be followed, but I'm not saying it in order to not be rejected. So a simple RNN would say 0.3. 0.3 is very low, but the user embedding RNN, which also takes as account the language of the user, takes who this user is and what is his rejection probability, would certainly reject that. So maybe it's also about not how many mistakes, this small increase in this aggregating measure can have a huge impact in moderator's life if it could systematically judge right such users. It's like solving one of his problems.
Sorry. Okay, if you take only this phrase,
yeah.
Right? Okay, I understand that the first 0.3, fine, but the 0.72, how are you able to get this number? Like, how do you train your data set in order to get this number? Because here we don't have any label, which is a bad thing.
The moderator rejected it. It's
He rejected it, yeah, but I mean, if you read the comment, it's not a bad comment.
It's not a bad comment, yeah.
It's not ironic. It's not in
I see.
the other labels you have.
I see what you mean. So yeah, I should go into more details. So it's the labels come from professional moderators. It's this huge data set we used. So we trained it to follow the moderator. We trained it to act like a moderator. So it saw like 100,000 comments that were moderated by professional moderators, and also the RNN.
Okay, now I understand. So the input is always Okay, now it's
So it back-propagated this information to the neural network and learned to.
okay, now it makes sense.
There's also an interesting comment from the other side. I mean, there was a comment, these are real comments by the way, it's not artificial. Indeed, I know nothing about the filth of Greek soccer. And RNN was quite high, probably due to the filth, probably to the negative. But the user embedding really accepted it, and it also followed the intuition of the moderator, who also accepted it, because this user was also having a good acceptance rate for his comments. And again, this was able to capture this aspect. So I'm going into to the last part of this presentation. Hopefully I'll try to finish in 15 minutes. I zipped it. It's all about context and my current research about it the last 6 months, and at least for me the most interesting at the time. So we want to evaluate the improvements to toxicity annotation when context is provided. So again, we are working on real-world comments from Wikipedia talk pages. And just for the sake of example, I took one comment, and I would like to ask you whether you consider this toxic. I mean, I do, but I would like also to do a really small experiment. So just raise hands, whoever thinks that this is a toxic comment. I have 2, 4. So it's like some are unsure, yeah. So who thinks now that this is toxic? I'm giving you just some context of it, like the comment above. Who thinks that it is toxic? Okay. Yeah.
Based on the context.
Yeah.
Depends a bit about the context.
Yeah, and I mean, it could be sarcastic, but again, it puts you in the zone. But then again, you see that it changes because it's the same user posting and increasing his intensity. So it's like it could context helps you understand more about what's happening. And this is just a parent comment, I mean. So what we did is did a pilot to get a better picture of what happens, and we give a questionnaire to 10. We prepared the questionnaire with the subtypes of toxicity, like obscenity, like sexual explicit and insulting, threatening language, and we created 100 questions, taking a sample stratified across toxicity zones. That is 10 varying toxicity zones from 0 to 1, and also adding a random sample. And some more restrictions, like comments not being too lengthy or maybe 1 character long, and not being section titles, because there are comments that act like section titles and the thread goes on. And we segmented, we created 4 different jobs. So the first job was to give 1 comment as the starting here small experiment did, and ask the annotators, 10 annotators per question, 10 different annotators per question, what did they think about it. A second job is to give them also preceding comments for the very same comments, give them the preceding comments in the conversation and see what happens then. And in a third job, instead of preceding comments, we give them also the titles of section and page. So having a picture of the topic, having a picture of what is it about. And this pilot annotation, the results of this pilot annotation, it gave us an interesting input that when we use preceding posts, the agreement of the annotators increases 10% at least, and when we give them titles, it decreases. So giving them context is not always good. It depends on what context will you give them. This could be, this could be because the annotator would try to guess what happened between the section title and the last comment. It could be like 10 comments long, or it could be that it could be many things. We need to investigate this more. We need a bigger sample, and it's the next phase. Sorry, yeah.
What do you mean by agreement?
We use Krippendorf's alpha. So what we did is we have 10 annotators, 10 judgments per question, and we're trying to see whether they agree in their label. The labels were 4. It was not toxic, unsure, toxic, or very toxic. And we use them as they were. One could also binarize it, like say, if you are unsure or not toxic, say 0. If you are toxic or very toxic, say 1. But we use these 4 zones, and another way to see the agreement.
So my question then is it the right parameter demand? Because if they agree on something without any context, well, is it good?
I see what you mean. So is the label correct or not? Or could they all misjudged?
Because they judge on something and they miss something because they do not have the context. That's my...
That's interesting because, again, I have the answer in the next slide, so I'll use that. So in order to explore what happens on these comments and see whether these, they agreed. Another way to see it is variance. If you see that they have these 10 judgments are high variant, they have high variance, you take the mean and you try to understand what this value, the average of their judgment is. If they are high variant, then this mean is useless. If they're low variant, it's like everybody said this is toxic, then you need to understand why they said this is toxic. It is less likely that all 10 were misunderstood. It could happen though. So we went on to explore this thing. We had exactly the same question. So what we did is take the 2 jobs, contextless and giving preceding comments which appeared to increase the agreement, and we computed the mean per question. So we have 1 judgment per question now, aggregating the judgments, and computed the difference between the 2 jobs. Ranked them, we see that it's not very steep. And
I just also have a question about the procedure. I do not remember exactly what you explained. So there are several people several humans that do the test. Do they try first without context? Everybody try without context and then with context?
That's a good question. That's a good question.
So yes.
I will elaborate more just right now. Just now. So usually, what you do is you employ 10 annotators. You give them 10 questions. You give them 100 questions, and you say, do this job without seeing any context. Then you should employ 10 different annotators, so they are not biased, and tell them the same and show them the context. We did not do that because it was expensive to do so, not in terms of funding it, in terms of getting this pilot experiment done in getting this first picture. So what we did is we used Figure 8. Figure 8 is a platform for annotation, which, in order to not bias your results, it secures that each question will be annotated by 10 different annotators, but also the next question will not certainly be annotated by the same 10 annotators. So we had like 35 annotators for 100 questions, and then we did a different job with different annotators doing the same thing. I hope I answered that. And going into the previous question now, that we found that most changes on this average toxicity per question happened going lowering this mean value. So we see here that from 0.9, that is toxic, it went into minus 0.5, that is not toxic, unsure to not toxic. And everything went lowering, except one, which is also probably noise after exploring it. So we went to explore some. I'm just giving an example here of a comment, which is mean, the value we were discussing, is 0.2. If we hadn't seen this variance, this would mean that the labelers, the annotators find this to be, they're not sure about it. But that's not true. If we see the variance, then we see that some label it as very toxic, some label it as not toxic. And probably this is due to the quoted stupid Wikipedian's phrase inside it, but it's quoted. And what happens in the preceding comments, when the preceding comments were also integrated, we get a minus 0.8 value, which is the true label here, since variance is 0.16. And this is an example of a toxicity reversal occurred when they were given the right context. So I'll speed up my conclusions here, at least for this part. These are very recent conclusions that preceding comments may increase the agreement of annotators. This doesn't mean, though, that the result is what we need. We need to secure that also variance is low. That is not we getting the wrong label here. And also section and page titles, not only they don't increase the agreement, but they could lower the agreement. What we need to do so is have a better pre-selection approach that could increase the examples given to the annotators, increase the context sensitivity, because now they show many comments, few comments that hadn't been affected by context, and also ease their way to annotate and perform a larger scale experiment and get more reliable results, also statistical significance, and with more annotators to get to put variance into the game. And I'm just closing with some questions I would like to answer in the right next steps. So the first is, how do toxicity detection systems perform in a context-aware data set? Do they label it correctly? Because this would mean that they know how to do it, even if humans fail to do it. Or what would happen if we retrain them in a way to give them examples, give them data that are labeled in a context-aware manner, having in mind that these data were used as hard cases. They were labeled probably as noise before, but now we're giving them to deal. The third way would be to incorporate context as a component, not only retrained in context-aware labeled data, but allow them to parse the preceding comments and maybe also titles or other information and encode that into an embedding perhaps and use that to again detect toxicity. Or another way would be context-dependent posts. These are posts that context is required to decide whether they are toxic or not, and these are a mission impossible for annotators if they have no access to the context, also to moderators in similar setting. So this dataset could be used to build a classifier to locate comments that need context and perhaps discard these from automated decisions, and they give these to human moderators. We need to spend much more time to go into the context. And if that works, it could also use for pre-selecting better. And I think I'm on time, so that's that. I would like to thank you very much, and I would be pleased if you have questions or any questions and go into a discussion about that at any point of the presentation. So thank you again. Yeah.
Maybe you answered it at the beginning of the presentation, I'm not sure. But do you have any idea how this could be put into production? I mean, is the idea to prevent people from posting toxic comments, or is the idea to...
That's very interesting. That's a very interesting question. That's a very interesting question. So far, detecting toxicity is in production in ways in APIs, used by APIs, and these APIs are incorporated by platforms. Some platforms are forced by law to do something to reject toxic comments, and this is the so far way that this has been established. My future plans would like to really test how users themselves can rewrite abusive posts. Would they rewrite abusive posts if they were given alternatives? Other questions are, do people agree when they try to rewrite a toxic comment? Does this toxic comment, when it's rewritten by humans, lose its meaning? is toxicity mitigated by this rewriting? All these questions are unanswered and are certainly in my agenda for future work. But since a lot needs to be done, it's not just a simple pilot experiment, see how people rewrite. I think we need to be giving them highlights, like this is toxic in this text, try to rewrite it and see whether this works or not. So basically the highlighting thing is the first step towards that direction that you mentioned. I answered, right? If anything more, just I can elaborate more. Great.
Are there works to identify humor, good jokes?
Yeah, there is basically specifically detecting humor in NLP is hard and useful, and recently I found a job about it, but I'm not so sure also about whether people would agree, because how do people perceive humor, and are there humorless people?
Yes, some don't like Belgian jokes. Yeah.
Okay.
Leo?
Yeah, my question was about taking into account the previous comments. Can you do some embedding on the comments directly, and then like attention mechanisms to attempt the comments that are related to?
Well, that's interesting. That's also a pointer to coreference resolution in some point that can you detect where does this comment, the comment that annotators see, which other comments in the preceding conversation is related to? Does it refer to like 3 or 4 comments above? Should one ignore everything else said? And this is the idea of integrating BERT and RNN, use the attention of RNN to find this, to highlight whole comments in a conversation. Maybe why not also exploit the attentions of BERT, which is also using a lot of attention and is not yet studied as for its possibilities. But I guess the first step is exactly that. Model its comment, have an embedding, and then have like a temporal or a sequential, like RNN, model its comment and lead to the last comment, which you will use to classify, also remembering what else has been said. So yeah, that's a very good idea, I guess. Any other comments, even if it's general, it would be, or feedback, I guess.
Do you have some examples of highlighting where the neural network discovered something like really surprising that the list wouldn't have found out?
Sure. You have an example in your mind? You have a comment that because I have a live demo.
In the toy examples you showed,
You're right.
The highlighting was.
Let me see if I can try something and get right back to you.
We see a difference in the score, so this difference must come from different answers to the same comment.
Well, that's a very good question, and surprisingly, it has not been done yet in any presentation. So let me check if we can find the answer together now. So let's have, yep. So this is from a previous project. We had built a demo. This is a stacked RNN using trained on Wikipedia annotated by jigsaw comments for a competition. So we can write here a text and see whether it highlights it right? So we can, if anybody can think of even sarcastic or humor, or maybe something that has no taboo words in it, I mean, we can be creative.
So if you enter the sentence about Greek soccer that was in the presentation,
so yeah.
I don't know anything about the field of Greek soccer. Will it?
Yeah, so let me, is it, I'll write it a bit wrong. Oh, let's leave it small. Oh, it's in a gray zone, but it finds it toxic, yeah. So this is trained on for the Kaggle competition. So not using user embeddings here really finds it even more toxic. So filth doesn't work well. But let's give it another try with an even more implicit toxicity. Maybe Leo, you can give us an implicit toxicity example. I think you.
Okay. Okay, check.
Or everyone. I think let's stress it.
Go away.
Go away. Try it. You don't know. It's my time finished again. Okay, let's go away. 74. So let's try.
Does it take into account
The length?
lowercase and application?
Yep. Yeah, this one does, I think. Let's see if I think, but because it was some time ago, this model trained. It was for the competition also. No, this one is case insensitive.
But if we write like something like, maybe you should take some vacation.
Yeah. Well, that's a context sensitive. That's a very context sensitive. But let's see what happens. So this is 5%. Yeah. So let's implicit. Let's give it forever. No, it doesn't capture. So it's context insensitive. Or it's even implicitly insensitive in many ways. But I mean, it also has the different. Let's say if we, I think if you give it a threat, I will try to find you, and you know anyway what will happen. So let's see what happens. So this is not toxic, but threat is a bit higher. But again, it didn't manage to do it. Yes.
And think by yourself, for instance. Think by yourself, or.
Yeah.
I guess it's toxic.
No.
And grow
In Wikipedia, it's anyway. This is a different data set. I think it most implicit toxicity. It fails because labels.
You had your example. Use your brain.
Oh yeah, that's a perfect example. So I'm probably damaging what I said so far using these examples, but this is current research, so this also gives me feedback. Surprisingly.
That's good.
Yeah.
So right now he's tagging brain as toxic, right?
Well, you know, this is not a toxicity. This highlighting is doing his work acts as following. Moderator, look what word you should focus in order to see why I consider this message to be rejected. So it's not toxic. Highlight doesn't act like toxic detection, toxic spam detection. This is the current work I'll try to make happen. But this is like trying to explain why it rejected the comment. So it could be.
So let's try another sentence with brain. I mean, brain is.
Yeah, that's
brain
good.
is amazing. Or maybe not your own, but not your brain, but.
Yeah, you true.
The brain.
The brain work is amazing.
So brain is it a bit.
It's very highly correlated with insult, it seems.
The
So that might be because people usually use brain to insult people.
Yeah.
So this also brings another idea to how some words include bias. How some words like the filth or brain here, and this is another subject. I mean, but
If you write gay, I think it will be.
yeah.
as an insult.
But so this is pre-trained with
So let's see. Yeah. It's affected by that, yeah, certainly. But this is trained on a much smaller data set. This is trained on 100,000 comments, so it's like one order of magnitude lower than the other. And well, that's also interesting to see something more here if I have time, just for another thing.
You learn the word embedding as well?
Yeah, we have
everything.
Yeah, all word embeddings were learned.
There's no pre-training. I mean, you could do
we use glove embeddings. I mean, we use pre-trained embeddings, and we use in another setting.
Pre-training would be less, for instance.
That's a good way to mitigate bias on words, yeah, and use frozen embeddings. That's true. So another thing, I missed that part of discussing, but I think it's worth to just point it out that we get great difference. I mean, if you see all the scores here, see for example list. List is a naive system. And it has 60%, 67, 69. Let's leave the correlation out of it for this presentation. And it performs bad. But what happens in Wikipedia is that it reaches 93%. So data set is easier, the least I can say. And also what we were seeing in these examples, it was trained in this data set, which is easier means a lot of things. So it's like the moderators agree in some stuff. Maybe this brings us into the previous question of what the labels are. They agree, but they agree in the right result. And many more questions I think we should get. And this is also a larger data set. It is in Greek. It is labeled from moderators, and this is from human annotators, which also gives more clean, probably, result. So, yeah.
Okay, thank you very much.
Thank you for the feedback.